Thank you very much for clicking our video. So if you have been watching our video, welcome back. If you are just watching our video for the first time, you are welcome. So in today's video we are going to talk about balancing of redox equation in acidic iodine. So in today's video we are not going to talk about only acidic iodine. I'm going to still tell you tips on how to balance this in basic iodine. We are very sorry I cannot read this introduction to redox reactions because this is one of the topics that was suggested by some of our subscribers. So if you want to be among those that will be suggesting topics, so you know what to do. Just subscribe, leave a comment and share our video. Then you can leave a video this thing. We are going to help you and also do the video for you. So in today's video we are going to talk about step by step on how to do or to balance this particular redox equation. So we are going to divide it into close to 6 steps, or let me just say 9 steps, in order for you to learn it very well. We're going to divide it into 9 steps. So we're going to start step 1, step 2, step 3 to the end. So I'll make sure in this particular video that I will make sure I break it down, that you not have what balancing of redox reaction as an issue again. So let's start. So in step 1, first thing first is for you to split this particular reaction. Split it into 2. So we are splitting this to we are bringing this and we call it 1. We bring this and this, we call it 1. So let's split it. Bring this, then we'll have this. This is the first step. You can see how easy as it is, and this is the step 1. Then step 2 is that we should balance these elements. We should balance it. So bring this. Now, how many atoms of manganese is in this side? Is just 1. How many atoms of manganese is here? Is 1. So it is balanced. So in step 2, you are going to balance all elements apart from oxygen and hydrogen. Apart from hydrogen, oxygen and hydrogen. Do you hear what I say? Apart from oxygen and hydrogen. So we are balancing other elements. So manganese here is 1. Manganese here is 1. Iodine here is 1. How many atoms of iodine here is what? Is 2. So you have to make here to be 2, so it will be balanced here. So what are we going to do? So you are correct, we are going to add 2 here. So we are done with step 2. So this thing is what? This is a balance now. So let's go to step 3. In step 3, you are now going to now balance oxygen molecules by adding water. By adding what? Water. So let's see how it goes. So first, we are now going to write this. So remember what I said in step 3, we'll balance what? Oxygen by adding what? Water. Where do we have oxygen here? You can see that in this particular question we had oxygen in this particular side, but we now have oxygen in this particular side. What are we going to do? It's for us to add water here in order to balance what? Oxygen. How many oxygen we have here? Is 4. So when we are now adding water, we'll add water in such a way that the oxygen there will also be what? 4. So remember, we now have 4 moles of what? Water. So that the water you have here is going to be what? 4. So for this particular question, we are not going to add water here. The reason is that we do not have oxygen in any of the side. We do not have oxygen in any of the side. So let's go to step 4. In step 4, you are now going to now balance the hydrogen ions. So that's step 4. Balance the hydrogen ions. Now, where did you add water before? You added it at this particular side. You know, now see that as you added water, there was hydrogen and there was oxygen in this particular side, but there's no hydrogen in this side. We have oxygen here, but we don't have hydrogen. In order for us to balance it, you have to know how many hydrogen ions you have here. 4 times, which is what? 8. So we are going to now add 8 hydrogen ions here. So at this particular side, we have 8 hydrogen ions. How many do we have here? 8 hydrogen ions. For here, manganese 1, manganese 1, oxygen 4, oxygen 4. So this particular question is balanced now. So for here now, we now also do what? We don't have we don't have hydrogen in this any on this side or oxygen on this side. So we leave here. So we now go to step 5. In step 5, step 5 has to be what? Addition of what? Electrons. Addition of what? Electrons. So in addition of electrons, what we're going to, so let's write this thing down. Let's write this thing down. So if we write this thing down now, you can see that first of all, let's now start checking where we have the highest charge. It's from where we have the highest charge. What we want to do here is that we want to make sure that the charge of this both side is what is balanced. So let's check how many charge we have here. So remember that we have just plus here. This plus means 1. 8 times 1 is going to give us what? 8. So for this part we have 8 plus 8. So for here, what do we have? We just had how many? 2 what? Charge. 2. So we now have plus 8 and minus 2 is going to give us what? That is what? Going to now give us what? Plus what? 6. So we have this particular side now. How many do we have here? We have, this is a compound. A compound, they say that the solution number of a compound is what? 0. For here, we have what? 2. For this particular place, we have what? 2. So we have 2 what? Charge plus 2 charge. Now, for this down here, what do we have? We have 1 here, right? This is minus, so that means minus 1. So 2 times minus 1 is going to give us what? Minus 2. So for here, for a molecule, the oxidation number of a molecule is what? 0. So now we want to balance this particular side so that this particular side will be equal to what? To the charges at this particular side. So for here now, if we say 8 minus 2 is going to give us what? 6. So for here we have plus 6 and here we have what? Plus 2. So for this particular question, so what we are going to do now is that we are going to make sure that the charges here is equal to the what? To the charges here. So which distance are we going to add to this particular distance? To add. So for this particular distance, if you're adding electrons, there's something you have to learn. You have to add electrons to the side that has the highest positive charge. For example, now let's assume that here, remember here was plus 6 before, let's assume that here is 0 and here is minus 2. We are just assuming. Which side is it that we're going to add electrons? 0 is bigger than what? Minus 2. So add electrons in this particular side that has the net charge as what? 0. So have it in mind. So here, let's go back to our question. So we have plus 6 here and we have what? Plus 2 here. In plus 6 and plus 2 now, which one is bigger? This is plus 6 side. So we have to try to add electrons in this particular side so that once we check the whole electrons at this particular side, it will be equal to the electrons that is here. Remember that the electrons that is here is plus 2. Electrons that is here, the total here is what? Is 6. So the charges that is here is 6. Charges that is here what? 2. So we are going to add electrons to this side. And electrons, if like example now, if we add 4 electrons here, what this is 4e raised to power minus 4. What this thing means is minus 4. That's what it means. If you say 8e raised to power minus like this, what this thing means is what? Minus 8. If you say 7e raised to power minus like this, what this thing means is what? Minus 7. Do you understand now? So if what are we going to now add here? So that when we add it to this particular distance, it's going to give us plus 2. So just think, Yeah, correct. So it's going to be what? 4 e raised to power what? Minus plus, that is 4 electrons. And remember what I said, this is going to be what? Minus what? 4. So minus 4 plus 6 is going to give you what? Plus 2. So that is for this particular side. Now let's now balance this particular one. If you now want to balance this, so we have how many electrons, how many charges do we have here? So how many charges do you have here? How many charges do you have here? 0. How many charges do you have here? Minus 2. So now what are we going to do? Remember what I said, you are going to add electrons to the side that it has what? The highest positive what? Charge. So what are we now going to do now? You're now going to, here is 0 and here is minus 2. So where do you think I want to add electrons? To this side. 0 is bigger than what? Minus 2. I told you before. So what I'm going to do here is just to add what we are going to add, so that here can be minus 2 and here can also be minus 2. What are we going to add? We now add what? Plus 2 what? Electrons. So coming to the charge now is now balanced. But here, or the next charge here we have here is going to be what? Plus 2, and here is going to be what? Plus. For here, minus 2, here is what? Minus 2. So we are done with the step 5. So in the step 6, now in the step 6, what you now want to do is that, remember in Redox reaction, 1 is losing and 1 is gaining. So if we have this one now losing 4 electrons, this one is supposed to be gaining 4 electrons. As this one is losing 4 electrons, this one is supposed to be what? Gaining what? 4 electrons. So that is what we want. So we have to make sure that the number of electrons is what? Is balanced. So that's what we want to now do. The number of electrons lost is balanced electron that is what? Is gained. So let's write these things down, back. So we now have plus now, remember what we did now. First of all, which side we have to find, this is 4 electrons. And here, how many is here? 2 what? Electrons. So we have to make sure that these 2 electrons is equal to these 4 electrons. What are we going to now do? We'll now multiply the whole of this side by 2. So that at the end, this 2 will now become 4. So we're not going to multiply anything here. So we only multiply this side. But for example now, what if here was 5? Let's assume that here is 5. What do you think we are going to do? Remember that 2 cannot divide 5, right? We'll now find the 2, the factor that these 2 and 5 can what? Can divide. So what is that? That is 10. So we'll now use here, we'll multiply 2 here, we'll now multiply 5 here. But in this particular situation, we will have 4 electrons. So what are we going to do? We'll multiply here by what? By 2. So that at the end, these 2 electrons will turn to what? 4 electrons. So this is step 6. So if we bring this thing down, we have 4 electrons plus 8 hydrogen ions now 2 times 2 is going to give us what? 4. And you think ion 2 times this is going to give us also what? 2 hydrogen molecule. 2 times this is going to give us what? 4 electrons. So you can see that the number of electron lost is the same as the number of electron what? Gained. So that is how it is. Now we also have so this is, let's move over to what? To step 7. Let's move over to step what? 7. In step 7, we are going to bring these things down. We'll now bring the full the full reactions. We'll merge these reactions and these reactions. So first of all, when you're writing this, you make sure that everything at this side is at this side. Everything at this side also merge at this side. Then everything at this side will also be this side. Everything at this side is also in this side. So let's start. Now, if we start this, we'll now say 4 electron plus this. Since this video is becoming long, sorry. I'm just trying to make sure that you understand this. Then plus this. Remember that I said everything at this side will be at this side. So now 4. Bring these ones. That is it now. So it is done. Now the next thing now is for us to cancel. For us to what? Cancel out excessive water. Excessive water here. So if we have excessive water, or first of all, you have to cancel electrons now. Cancel electrons. How many electrons do you have here? You cancel electrons. You cancel what? Electrons. Do you have water at this side? No. Assume that we have water at this particular side. Let's assume we have 16 molecules of water here. Let's assume. And we have 4 this thing. You have to now subtract. How many do you have here? This thing now we have to subtract. That means here will now remain 12. And this one will go. But this particular situation, we not have this thing here. We not have any water here, right? So that means we are what? We're not going to do what? We're not going to cancel out anything. So at the end, we have this. Let's check whether our charge is balanced. So how will this thing is now balanced in acidic medium. So this is balanced in what? In acidic medium. Acidic medium. Let's check whether the charges are balanced. No. How many charge we have here? That's plus 8, and here is what? Minus 2. So at the end, the net charge is going to what? Minus what? That's going to be what? Plus 6. Then for here, we have 2 here in this particular distance. So, okay, I forgot 1. So here is going to what? Minus 4. At the end, our net charge here is going to what? Plus 2. Not plus 6 because I forgot this last one. So at this particular place, we have 2 here. This one is going to be what? 0. Remember that molecule, the net charge, the oxidation number is going to still be what? 0. So at the end, we have plus 2 here. So it is what? Balance. Let's now assume again, if you're now asked to balance this in basic medium. For now, this thing is balanced in what? In acidic medium. This is, we have answered our question. But remember, when we started this video, I told you that I'm going to give you tips on how to balance this in also in what? In basic medium. How will you know base? Hydroxide, right? Hydroxide ion. Hydroxide ion. So that's how you know it. So if you are asked to balance this in the basic medium, so what I'm going to just do is to add OH. In this particular side, we have what? Hydrogen what? Ions. In order to neutralize this, that is now turned to step 8. So it's now turned to step 8. So let's just check again. We'll add OH. How many OH will you add here? You add based on the number of this hydrogen we have here. We have now add 8OH negative. Now you also do the same here. You now say plus 8OH what? Negative. So at the end, this one now will neutralize this and form water. So you now form water now and form 8 moles of what? Water plus okay. So now, remember now, how many water did you see here? 4 moles of water. So we are going to subtract these 4 moles from this particular side. If we subtract, this one will go. So how many do we remember? How many is remaining here? 4. So we write this here. This is going to be like this. the arrow, this plus this, it's OH negative. Now this is now what? Balance. So now have, this is now in basic medium. This is in what? In basic what? Medium. This is balanced in what? In basic what? Medium. So if one wants to check, how will you know this is in basic medium? Hydroxide what? Ions. How will you know this is in acidic medium? Hydration what? Ions. So this is it. So this one is in basic medium, this one is in acidic medium. So if they say you should balance this in basic medium, have it in mind, you start from acidic medium before you enter what? Basic what? Medium. So that's all for our video today. Hope you enjoyed it. So if you want to see one's LFS to keep functioning, keep smashing that like button. We are there for you. Make sure that we will do this till make sure you pass your, make sure that we are there to pass your exam. So we have also one more question on this particular lesson coming up. So make sure you are there. Stay tuned. The part 2 of this we will also solve some questions. Try the ones that students are finding difficult, both in Waec, Jamb, and this thing. So see you later. We'll keep finding your X. Thank you.